Welcome to a little video about Target 5A, where we're going to use the rules of probability to compute probabilities of compound events in a uniform probability model. Now, first things first, probability is the likelihood of an event to happen. So, let's take a look at this bag of marbles. The first question I had is, what are the possible outcomes? I already have that written in because I'm pretty sure you can see we have black marbles, white marbles, and striped marbles. Okay, now the first thing we need to look at is the probability of pulling a striped marble. Now, what we do to do this is first we look at how many striped marbles are there. Well, there's 3. Great. Now let's see how many marbles are there total. I counted them up. There's 10, and that goes in the denominator of our fraction. And that's our probability. Let's take a look at number 3, probability of not pulling a white marble. Once again, I have a total of 10, so I'm going to put that on the bottom. Not white, I'm going to count them up. There's 4 of them, and let's reduce that to 2/5. We always want to reduce probabilities as far as possible. And number 4, probability of pulling a polka dot marble. Well, we still have 10 marbles, none of which are polka dot. So there's 0 chance of pulling a polka dot marble. All right, independent events are events that don't affect each other. When we have independent events, you usually see the word "and" in your problem. That means we're going to be multiplying 2 probabilities. So here's some independent probabilities. We have a dice and a letter spinner. They don't affect each other. They're 2 whole different things. So we're going to find out their probabilities by multiplying them. All right, so first I want to see what is the probability of rolling a 2 and spinning an A. All right, well, rolling a 2, that is a 1, there's 1 2 on a dice that has 6 sides, and means multiply. There is only 1 letter A in our wheel that has 5 letters, maybe, if it wants to write it for me. There we go. I think instead it's choosing to draw this really long line over here, and I'm not quite sure why. Oh, I see. I think I must have leaned on something. Thanks for your patience. Here's the 5. All right, let's multiply. 1 out of 30. Let's continue and erase some of these crazy lines I just accidentally made. The probability of rolling a number greater than 3 and spinning a vowel. All right, so my die still has 6 sides, and 3 of those sides have a number greater than 3. I'm going to multiply it by the vowels. There's 2 vowels on the wheel out of 5 letters. Multiply straight across. We get 6/30, which I can reduce to 1/5. Let's do one more. Rolling a 5 and spinning a constant. Well, on the die, there's only 1 side with a 5 out of 6 sides, and means multiplying. There are 3 constants on our wheel of 5 letters. Multiply straight across and reduce. Perfect. Okay, so again, these events did not affect each other at all. They're 2 whole different things. Therefore, we used some multiplication. Now, that doesn't always happen. Sometimes we have disjoint events or mutually exclusive events. These are events that can't happen at the same time. We will always hear the word "or" when we're doing these mutually exclusive events. And when we see the word "or," we are going to be adding the probabilities. So let's take a look at what is a mutually exclusive event. In number 9, we have an example. Rolling a 5 or rolling a number less than 4. If we want both events to happen, we have to add them up because they are on the same die. Now, in the last problems, we had a die, roll, and a spin. This time, we're looking at that same die, either rolling a 5 or a number less than 4. So that's a totally different way of looking at it. So, rolling a 5. There is just 1 5 out of 6 sides for the die, plus because it's OR. There are 3 numbers less than 6. So, let's add them up. 4 out of 6. Let's reduce 2 out of 3. Now let's look at the spinning wheel. Same idea. If we want to calculate the probability of 2 events that are happening on the same object, we need to add them. So spinning a constant or spinning an A. All right, there are 3 constants out of 5 parts of the wheel. OR means add. There's only one A on the wheel, so we have 4/5 as our probability. Number 11, let's do just that one. We don't have to do number 12. We're going to do both independent and disjoint events. First, I see rolling a 2 or a 4 on the die. So those go together. They're on that same object. So there's only one 2 on the die, and there's only one 4 on the die. And the die has 6 sides. And means multiplying. So I'm going to multiply it. But why isn't it drawing it? Oh well. Come on. Come on, OneNote. Love me. There we go. Times. There's only one E on the wheel. 1/6 plus 1/6, that's 2/6. I'll multiply it by 1/5. 2/30, which I reduce to 1/15. Again, I added the things that happened mutually exclusively. So the rolling of the 2 or 4, that happens on the same die. So I'm going to add them. Then I multiply it by the independent type of event, which is spinning the wheel, because that has nothing to do with rolling the dice. And a cute little cartoon here. I wish I'd learned probability, because I think our odds aren't good. I don't think our odds are good. That's so cute. Yeah, of course, waiting at the principal's office, somebody's in trouble. Okay, part 2, we have independent and dependent events for 5A. Let's take a peek. Independent events are not effects. Oh, Miss Gumin. Not affected by previous events. And dependent events, they are affected by previous events, such as an item not being replaced in a bag, which is generally the type of thing we like to look at. So, example number 1. We have a yellow marble, 2 green, 4 red, 5 blue. They're in a bag. Once a marble is drawn, it's replaced. Let's find the probability of each outcome. Now, is this independent or dependent? If I take out a marble, and then I put it back, and then I take another one out, that means I'm always starting off with the same amount of marbles. So no matter how many times I pick a marble, I'm still going to have the same chance of picking that one again. So this is an independent event. There's no effect. So we have a blue, then a red. Okay. So blue, that's 5/12. Then a red, that's 4/12. All right, let's find their probabilities. Now multiply and reduce. Oops. Okay. Let's take a look at letter B. 2 green marbles in a row. All right. There are 2 green marbles in total out of the 12 that we have. I pull one out and then I put it back in, and I still have 2 green marbles in the bag of 12. So let's multiply straight across. And of course, reduce. Boom. Well, what does it look like in example number 2? When we do not have things being replaced. All right, I don't know if you see this. I just got a message on my on my computer. Sorry about that. If I interrupted the video, I'm too far in to restart it. No. So, same bag of marbles, but now we are not replacing them. So is that dependent or independent? Well, that would be dependent, because if we don't replace the marble after taking it out, we have a different amount of marbles in our bag for the next drawing. So let's think about that. If we're, sorry, I was trying to zoom in, red then blue. Okay, so there are 4 red marbles in the bag of 12. Let's say I pull one out. Now I only have 11 marbles in my bag, and 5 of them are blue. Multiply straight across, reduce. All right, how about 2 blue marbles in a row? Okay, well, I started off with 5 blue marbles in a bag of 12. I take one out. Now my bag has 11, and I only have 4 blue marbles in there. So I'm going to go ahead, multiply, and reduce. Okay, there we go. So those are your dependent events. And that is it for Target 5A. If you have any questions for me, please don't hesitate to ask. And have a wonderful rest of whatever day it is for you. Bye.